Hello everyone, this is the second lecture, or we can say the first lecture, because we were starting from zero, of course, as we are programmers, right? So in this lecture I will tell more about variables, some arithmetics. I will tell about some operators like while. I will explain some white space indentation. And before we start everything, I want to mention one important thing, that if you want to actually become a C programmer, you actually need to write code. Okay, so if you can't learn programming by just viewing it, just listening it. Okay, if you are reading a book, try to run everything you see. Okay, if you are watching this video, especially from mobile devices, by the way, I've increased font size, so it will be comfortable for you to to see the code, the source code. So if you are watching from mobile, you probably need to rewatch it again, because and run it, compile it, and run everything. Okay, so practicing is very important. Okay, otherwise it's useless. Okay, so today we are going to write some program which will convert feet to meters. Okay, so let's create the new project. I've decided to create new project for every new program, and let us name it. Let us call it length table. Okay, length table, and let's create it. Okay, so we are doing the same thing. We're adding a new item. Okay, and picking up here a C++ code, and removing pp part, and we're done. So we have source code. We include the same library, which we'll use it before, because we will use also printing facilities here as well. So that's the bare minimum of what we need to start to write our program. And before we continue, I would like to introduce some concepts in programming. Okay, so as you see before, our program was consists of two functions. Actually, we have just printf function with hello world, right, and another function main. We never used here variables, but today we'll use the variables. So what is a variable? It is something which helps us to store value and modify it during the program execution. Okay, so variables have different types. We can store different information, different kind of informations, like we can store symbol, we can store character, yeah, right? We can store numbers, and numbers are different. Okay, so we have integer numbers without a floating point. All right, it's just a whole number. Okay, and we have floating point numbers types, yeah, and basically that's it. Yeah, just let's try to create some variables. Okay, so variable has data type, and it has its name. Okay, so let's try to create some variable. First we write a data type, Okay.
Okay, let me explain what is a variable again. So variable is a concept that allows us to store some values, some information, data in our memory. So our memory is a contiguous array of uh, bytes. We can assume like that. And when we write something like this, we tell compiler to allocate memory for storing integer numbers, which will be identified by the name foot. Okay. Also, we have an initialization here. We can initialize something or not doing that. So initialization is like given a starting value, the value with which it will start. This variable will start. So according to the name of variable, it can vary. Yeah, okay. So if you want to change this value, you can later on assign to this name another value. Okay. So um, so let's try to create few variables and let's try to write the whole program. Okay, I will explain everything. Okay, so let's try write this down everything. So we probably need to um, declare another variable which is millimeter. Okay, so we can initialize it, but here it doesn't matter actually. And what we are doing here, yeah. So how we are writing our program, what we are trying to accomplish. Actually, before writing any code, try to think about what you are going to achieve, right? So we want to make a table. We want to convert some values from um, from feet to meters. So it would be like 1 feet equal to 304 millimeters. Okay, 2 feet is equal to 609 millimeters, and so on. So we want to achieve this goal. We want to display, calculate it first, and then display it on the screen. Okay. So that's what we are trying to achieve. For achieving this, we need some arithmetical operation like multiplication, because when you convert from feet to meter, you have to multiply um, by some value. Okay, it is 304 millimeter. So 1 feet is one foot is 304 approximately. The second feet is 609, and so on. Okay. So let's also we will have something which will define our bounds. Okay, so our bounds of table, we just can't do infinite table. Okay, so we're starting with value 1 and we are ending with the value 30, for example. Okay, and also we make each step in increment step equal to 1. Okay, so what we are going to do here, so we are specifying that our program will calculate all foot, how many millimeters are certain foot. Okay, so it will start from 1 and it will go until 30. So we are just declaring variable here. It does nothing yet, nothing meaningful yet, because we just declared it. Okay. Okay, so we have declared here a whole bunch of variables. So what we're going to do next? What is the core of our algorithm? The core of our algorithm is that we want to um, calculate for each foot value how many millimeters is it. Okay, so we are doing it like for each value we do the same step. So for in order to make such kind of operations, we need to define loop. Okay, one of the loop constructions in C is while construction. It's written like this. In while loop, something is executed several times. Yeah, and depending on our condition, if our condition is true, it will keep going on executing and doing the same thing the whole time. But before diving into while, I would like to explain how the program is generally, how the program flow generally is moving. So the program starts execution from the first line, and it goes through the next lines. Yeah, um, but there are some exceptions. Um, we have functions which, when we call functions, we some kind of break our sequence of execution. So the program can really have very complicated path of execution. It's not always that straight. I would say that it's never that straight. However, if we call some function, for example, let's say that operating system actually called this main function. When we enter to this function, we are going to execute everything between two squiggly curly braces, okay? And it will start executing from line 4, but here is an empty thing. There is no operators, so it will continue on line 5, 6, and so on. The same thing happens with while operator, and this part of while operator is called body. Actually, this part of the function is called function body. So they are the same concept, that something is enclosed between these two um, parentheses, curly braces. Yeah, okay. So while we'll try to check the condition, and then if this condition is true, it will try to execute. It will execute until this condition is true. So we have condition is written in this round parentheses, and we have to write here some condition which will suit our needs. So here we are going to write something like until foot, okay, is less than upper bound. Okay, we are saying that we want to loop through this some and do some actions until until we reach the upper bound of our table. Okay, so what we can say here, that we want to calculate millimeter, and to find out how many millimeters some value is, we should multiply foot by special constant, which So each foot is 304 millimeter roughly, and with some floating point part to be more precise. Okay, so in this variable we will store the value for the converted value for each foot value. Okay, and then what we're doing here, we are incrementing foot. Okay, so not really incrementing. Let me write it this way. We are saying that step further, and our step is 1. So also we forgot. Let us initialize foot here with lower bound. Okay, so this expression does mean that we're starting with the lower bound, which is 1, and then we're going through loop and trying to make similar, perform similar actions, similar calculations for each value of foot variable. Okay, and then something in between, we want to use printf function to output our calculated values. For doing this, I will write something which is quite cryptic, but let me write it first and then I will explain. Millimeters, okay, and let's write here foot and millimeter. Also, we can write here a new line after each print function, and let's see what we get. So I will explain in detail what is it. Okay, so we can see that we have some actually we have some error here. Okay, so what we see here, we yeah, here's a mistake. Let me fix it because we have different data type. And okay, so as you can see, we have a table. It's kind of table, and for per each foot we have millimeters value. Let's try to understand what's going on here. So we know that print function helps us to output something to the terminal. Okay, and before we used some string just as it is. Okay, and now we're going to make some substitution. When we want to put certain value to the string, but we don't know which value it will be in future when it will be executed. Okay, so we cannot here just write 3 and here just 900. It doesn't work that way. Yeah, that's the whole sense of our program. We don't want to make it make manual calculation. We want to write a program which will calculate everything, and of course our variables are changing each time, and we want to output certain values. Okay, so we want to output that for 5 it will be 1524 millimeters and so on. Okay, so let me explain this a little bit more. So we want to output foot and millimeter values, and we use something which is called format specificators. And this format specificator is a combination of percent sign and D sign for integral type of variables and for floating point variables. Okay, so we're kind of substituting this part. So when we got to this place, we will have the values of foot and meter calculated already, and we can just substitute it there to this string. Actually, you can write it something like this. It doesn't really matter what you write in between. It will just affect how user will see this calculation. Okay, that's how it works. And the next line, we're increasing our foot to the next value. Let us try to debug this application. Actually, there is no errors, but at least we don't see anything strange here. But we will try to debug this application. So debugging is a process of finding some finding an errors or some mistakes in program when your program misbehaves. Okay, so this process is kind of when you're stopping execution of your program and you are doing all this all instructions step by step. So when I start my debugging and I put a breakpoint, it's called breakpoint, and my program jumps here, it stops here, it's like a stop sign, and it stops here. Then I can run my program. I can step each expression, each line by itself. Okay, so let's start this one and let us debug by step over. Okay, step over is when we go through the program to the next line. So currently the value of millimeter is 0.0. Then we execute lower part, upper part, and we see that lower and upper are assigned to 1 and 30. Step is assigned to 1. And then you can see that foot is something strange value here. It is because we haven't initialized it and it filled with garbage. So we don't want to work with garbage, of course. We want to make our program do meaningful things, not strange things, and of course not misbehave or do wrong things. Okay, so we're initializing here foot, assigning foot as a lower bound. Okay, so our foot is now in lower bound. Then we came up to we come up to while loop, and here how this while loop is going to be executed. First, it will check these conditions and whether it's true or not. Let's see foot value is it's 1, and we see that upper value is 30. So 1 is less than 30. What does it mean? That this expression is true. And if it's true, then while will jump straight in to the body of the execution of while. Let's jump in. And we see that it goes to line 14. Then we have in line 14 execution of calculating millimeters. Okay, so we have 1 foot and we want to calculate it to meters, and we see that millimeters has now value of 304 with some floating points. Don't really pay attention to the floating part of this. It's not the scope of this lesson. Okay, so we have currently millimeter value, and we have foot value now is equal to 1, and millimeter value, which is calculated, and we are ready to output first pair. Okay, first pair of foot and millimeter. So now using printf function, you can write output some string to terminal so user can see it, and you can, using format specifier, you can substitute certain variables. The current value of that variable will be written to the corresponding specifier. So this one will be substituted with the first variable, which is specified as a next argument. So arguments in function are divided by commas. So this one will be substituted by this one, and this one will be substituted with this one. So actually, this function can take any number of arguments. If you want to write to add here something like this, for example, you want to output it in meters. Okay, so let's write it this way. So what you can do here, you know that meter is 1,000 times more than you can just multiply millimeter to 1,000 and you get meter. Okay, so you can actually output meter here as well. So it's up to you what you want to output, what data you think that it will be useful for your user, and so on. So you can do here a lot of stuff. You can output and substitute whatever number of variables you want, and then we go to the next line. Let's see what is the result of printf. So we see that one feet is equal to 304 millimeters, and then we are going to this line and see that foot is here 1, and step here is also 1. And this line is kind of strange because in mathematics this will be absolute nonsense, because foot cannot be equal to foot plus step. This is not the equation, it's rather an assignment. When you assign a new value to this variable according to the result of the right part of the assignment operator. So you calculate this expression, and of course it will be just 2 because foot is 1 and step is 1 as well. So it will be 2, and this value will be overwritten to new foot variable. So as you can see, foot variable is here is now 2 equals 2, and be careful. What is going on here? After the line 17, it doesn't go to 18 or next lines. Yeah, it returns back to the line 12, and going through the this condition checking again. So this time foot is 2 and upper is still 30 because we didn't change upper value here. It's something which we stick with. Yeah, they are bound. Lower and upper are bound, and we do not change it in this in this loop. We don't need to change them. So foot is 2, and then we go to the line 14 and calculating how many millimeters 2 foot is. Okay, so we see that the 2 foot are approximately 609 millimeters, and we are going to print this pair again. So as you can see, it will print out in this line 2 feet 609, and then we go again to this line. We see that foot is now 2 and step is still 1. Step is also static, so then our foot value equal to 3, and then we again jump here to the line 12. We see that foot is 3, and upper is 30, and we're doing everything, every instruction inside of body for each foot. Okay, so we're going to do all. Okay, so it's kind of looping. We see that already 11, and we will do this. I will not do this 30 times. I just play continue, and it will execute the rest of the code. And then when it's 29, it sees that 29 is less than 30. It outputs actually 29, and here foot became 30 because 29 plus 1 is 30. So foot becomes 30, and it goes here checking if 30 is less than 30. Definitely not the case. So the value when foot is 30 is not actually going to be calculated. To fix this, as you can see, we have only 29. To fix this, we need to add here an equal sign. So the combination of those two signs, less and equal, will tell our while loop condition that even if foot is equal to upper, still execute those instructions. So it's an edge case. When foot is 30 and upper is 30, it will still execute. Okay, so let's check this one. Okay, let me continue this, skip this breakpoint this time. Okay, and we see that 30 is also now in our game, right? So, okay, so that's it for this lesson. I don't want to make the lessons too big. And the next part of this lesson will be in the next video. So stay tuned. Bye.